Hello, I'm Jason. Welcome to this lesson of the AC Analysis Tutor. What we're going to do now is pick it up from the last section. We had a general overview of what alternating current is. We said that alternating current literally comes out and in, and then out the other way, back in, and it literally switches direction so many times per second. For a wall socket, it's 60 hertz or 60 times per second, but we're going to study in our circuits many different frequencies, and so all of the techniques that we're going to use is applicable to any problem that you have. But before you go any further, I want to give a little bit of review of trigonometry. Not a long review. I think you really need to have some skills from back then, but I do want to take a few seconds to show you something because it is going to tie in. So let's look at the plot of sine of theta, right? Theta, remember, is just an angle. So you can represent angles in degrees, 360 degrees in a circle, right? You can also express an angle in radians. There are 2 pi radians in a circle, right? So it's a conversion factor, 360 degrees in a circle, 2 pi radians also in a circle. So here is sine of theta plotted against theta. Now I'm not going to be exact with this. The point of this is not to be exact here. But what I want to do is just kind of show you what it generally looks like, because you kind of need to have this in your head a little bit. I think it's helpful. Sine functions, just plain sines, sine waves, however you want to look at it, pretty much look like this. They start at the origin. That's where it starts. It goes up and then down, and then up, and then down, and then up, and then down. Notice my little marks. I'm trying to evenly space them out. That's a pretty decent looking sine there. And the thing that you need to remember, a couple things I want you to remember, is that it starts at the origin. So the starting point starts at the origin, and it goes up to +1, and this goes to -1. So that's what a sine looks like. Now, what are we plotting against? We're plotting against angles. So all you're doing is you're putting an angle in here. In circuit analysis, believe it or not, you deal with degrees sometimes and you deal with radians other times. So it's important that you have some familiarity with degrees and radians. I already talked about that a little bit. Basically, you're plotting the angle in here and you're getting the sine function as a result of that angle. So it goes up, it goes through 0, it goes to negative, goes through 0, and you can see it's cyclic. It just keeps kind of doing the same thing over and over and over again forever, basically. Now, if we wanted to compare that with cosine of theta, it would look similar, but there's an important difference. And the reason I want to show you this, even though you probably already know this, a lot of you guys, I want to show you this because it is going to be helpful for you later. So let me put my little marks here as best I can. I'm not trying to be too terribly exact. Cosines do not start at the origin. Cosines start right here. So if you had to do that, cosine would come down here like this, and then it would be up like that, reach a peak like that. Okay, something like that. All right, so when you look at this here, the maximum that the cosine gets to is +1, and the minimum that it gets to over here is -1. So I want you to stare at these, and remember that I'm not an artist, so they don't look exactly perfectly right, but they get the point across for what I'm trying to show. First thing is, I want you to know that both of these functions, sine and cosine, have a maximum value of 1 and a minimum value of -1. So the extent of the height of the function is always plus or minus 1 for sine and cosine. The other thing I want you to remember is that the shape of these guys look identical. If